Hello, everyone. Please welcome our dear panelists and hosts on this panel session. Let me quickly introduce our panelists. From the right side, Chief Technology Officer Robert Bogucki. He has built and currently oversees deepsense.ai's technical team. Then Przemysław Biecek, who is a professor at the Warsaw University of Technology and the University of Warsaw. He develops tools, methods, and processes to explain predictive models dry by AI. Piotr Sankowski. He is a professor at the Institute of Informatics, University of Warsaw. His research interests focuses on practical application of algorithms, ranging from economic applications through learning data structures to parallel algorithms for data science. Pablo Ribalta, who is a deep learning algorithms manager at Nvidia, Warsaw, holds a PhD in machine learning and artificial intelligence by Silesian University of Technology and has extensive background in academia and engineering. Our last panelist, Stanisław Jastrzębski. He serves as the CTO and chief scientist at molecule.one, a startup solving the chemistry bottleneck in drug discovery. He gained industrial experience at Google, Microsoft, and Palantir. At heart, both interpreter and scientist. And our dear host, Michał Zmysłowski, who is an ML in PL Association co-founder, and in 2018, he was a project leader in ML in PL conference. And the stage is yours.
Thanks. So hi everyone, thanks for coming to the panel. Today our panelists will be talking about AI in industry and academia. And bridging these two areas is at the heart of our conference. We believe that the most important innovations happen right at the edge of the phase transition, where two different states can coexist. That is why we invite both engineers and researchers to show their results and interact with each other. And I hope that this panel will be another opportunity for this. Without further ado, let's get started. So my first question to the panelists, and everyone can answer who feels the most comfortable, is how can business and academia help each other, and what are some good examples? Maybe.
Does you want to take it? Anyone wants to take it? I can take it, but maybe you can start and I can finish.
Sure. Once I can start. Kick it off, sort of. So, yeah, my thinking about it is that it's important that academia and industry both understands its role in actually pushing things further. And for academia and research in general, I think it's more important to focus maybe on the methods and stuff that industry wouldn't maybe touch right now because it's not so needed as of now. And for industry, it would be more to focus on, let's say, tools, on practicality and everything that we need in order to make it work as of now. And then there has to be feedback from one side to the other one. Like, of course, scientists have to know what business would like to use, in what context they would like to use it, and what they need in order to, at the end of the day, make it practical. And the other side of the coin, so meaning the industry, it has to feedback all those information. So it has to give back to the whole research, to the academia, letting it know what the context and what the actual use actually looks like.
I would say I agree definitely. Okay. No? Yeah, I definitely agree. Maybe to add to it, I think it was Hinton who said that the future of, I think he said deep learning depends on like one graduate student who disagrees with me. So I think the role of academia largely is to look at what industry is not incentivized to look at. And that's definitely something we, for example, I think should do more in Poland, so try to build towards what's next in academia. And maybe to add also, it's also interesting that it can go the other way. So when industry discovers something that is under research but could have been only discovered in industry, it's often nice when this goes back to the academia. So I think scaling models is one thing. So no one in academia could have done what Google or OpenAI have done. But also industry is not yet that great at understanding why these big models work, and that's a big research area.
Maybe I can go? Yep. So I agree with Staszek, and the question was about how they can cooperate. And sometimes what I observe is like there is more than one way of cooperating. Research, academia has its own goals, industry has their own goals, and the same way that academia can support industry, it can work vice versa. So usually industry cares about a set of things, mainly just make money, developing new tools that people can use, and academia can focus more on other things. But to take it to the next level, industry can benefit from researchers, but also researchers can benefit from the help of academia. I see this every day. We support universities, with hardware and things like that, and this is something I observe. There's plenty of people who are super smart, and industry can help them, take it to the next level by helping them with hardware or tools. And likewise, you can really innovate much better if you can, support groups who don't have these same constraints as industry, and release innovative products that really change the landscape and bring a lot of benefits. So cooperation goes both ways. There's opportunities for both.
So maybe I'll comment and tell what we do at Ideas. So I mean, something which actually is kind of was created in response to what we are discussing right now. So to how to kind of make this cooperation better between academia and industry. And in the response to this, we created Ideas NCBR, which is a new research center which started a year ago. And essentially, this is a place when you can combine two things. So you can come, do your PhD, for example, at Ideas, where we support give quite cool working conditions, and then you can really concentrate on your research projects and cooperate with tons of people as well with industry. And I think this is kind of, I really hope, this will be kind of a new hub, an AI hub in Warsaw or in Poland. And I think that this really kind of answers and fill up some gaps which so far have been present in the in Poland, and maybe they are not that visible outside of Poland, like in US, when there is no salary gap or less salary gap between working at university and in industry. Whether in Poland this is really challenging. So we need some programs to support young people. Doing research in AI and related things, and Ideas. I think this is kind of an answer, and I hope will actually contribute to this cooperation between academia and industry.
Yeah, so I agree with all colleagues. Just to add to this, maybe two points. One is related to teaching, because a big part of our life at academia is teaching, and I guess that here we can help each other both directions. So I guess that there are some skills at academia, and maybe business needs these skills, so we can kind of organize some trainings or other activities. And other direction is that maybe there are some new technologies, new resources, new methods tested, developed in business, and maybe they can be translated to academia offering to teach students of these new methods. And second is also research groups. I guess that in academia you might have a new research group that is focused on some specific niche, and maybe business would like to consult with these research groups. So I guess that these are possible ways, and they are happening. So at least I guess in both Warsaw universities of technology and in this one, these two collaborations are happening right now.
All right, thanks for your answers. So maybe let's swiftly segue to the next question, which is kind of related. So what are the challenges in the cooperation between business and academia?
Maybe I can take that one first. Okay, so from my experience and the way I see it is sometimes the challenges come from the lack of alignment between objectives. Usually in industry, the objective is to make money as soon as possible, just to put it plainly. And in academia, you can spend more time developing methods, understand them in detail. But ultimately, the main difference I see from my perspective is that we are all familiar with the triangle between quality, time, and money. And you can only pick two of them, usually when you are in industry. But in places like Nvidia, and I guess this applies also to other companies of that level, there is yet another vertex to that, which is the opportunity cost. You want to be the first one because you want to, let's say, lead the market. You want to be a leader in a particular method. And being fast to react and to put products out has a lot of, let's say, it's very rewarding because you can be, let's say, you can capture a big part of the market and benefit greatly from that. When you work, for example, when you have a partner who is in academia and they don't operate with opportunity cost as one of their constraints, sometimes it makes these cooperations, let's say, you have to aim for longer term cooperations. And this lack of alignment between objectives, I see that is usually what makes this type of joint work a little bit difficult. But at the same time, this doesn't mean that the concerns from either party are less valuable. You simply need to focus on maximizing the outcome of both parties, and sometimes there are some scenarios where this might not be feasible, but usually projects that are some years in the making, they deliver even more groundbreaking progress. So I would say, in summary, alignment between objectives is what I see. It's that.
So maybe I comment on the biggest challenge I see right now. So I think, we kind of are happy to see all the, companies coming to Poland, like deep tech. Google is buying a huge building in Warsaw, and we seem to be happy about this. But kind of the drawback is that all these industries, including Nvidia, are sucking up all the people from universities. So this is what's happening. And you might think, okay, what's up with this? But if you talk to kind of department heads, in different places, they are really afraid that they will stop teaching computer science at universities because there is no people who actually chooses the academic path. Yeah, so I think it's a huge challenge, and we should solve it somehow. So don't be afraid to do science and stay in academia, to engage in really interesting projects, and we really need some new blood in doing research, and I hope the things we all do and in different places will actually keep people in Poland, keep them working in Poland, keep doing excellent research, and publish top research papers in top conferences, and I hope next year we'll even have more cool talks here from people who actually had top-notch papers in top conferences. So I hope we can do something, but there are really huge risks which we kind of are not aware, and they are really caused by the fact that industry is growing. So if you look at this department. Yeah? So I mean, we have been kind of teaching or kind of graduating the same number of master students each year for like 15 years so far. In the same moment, like the industry in Poland, like IT industry, grew by a factor of 2 or 3. Yeah, so it's certainly, we cannot keep up teaching people. Yeah, so it's, there will be bigger and bigger kind of challenges ahead of us.
So I'm really glad that we stop agreeing with ourselves. But actually I have really similar opinion to yours, that one of the biggest challenges is the resource that cannot be easily multiplied. And the resource is, of course, people with skills. And I guess that the academia perspective is that here we can group people, teach them new skills, help them develop. But this bad business is sucking these guys very, very early. It's not maybe bad that they are working at academia, but the problem is that they are working at year 1. So maybe this is a problem. So what we can do, I guess that there are options, there are good options, but they require a lot of trust. Both sides need to trust each other. That one side is that, okay, let them grow, and then we can maybe benefit having more experienced, skilled people. And second part is that, okay, we can keep our business as usual, and now I'm talking about academia. We can keep our business as usual. We can teach people because we have still enough staff to teach people. And this is a serious problem. I'm teaching at both places. I supervised at University of Technology, and here we could have much larger number of students, really great students, enrolled, but we do not have enough staff to actually teach them, serious courses. So I think that the challenge is trust, and the problem is with limited resources here, people.
Maybe to add one perspective, so I agree that business sucking up researchers is a problem, but I wouldn't say it's, let's say, fault of students going to industry. I think that academia in Poland should generally, you could say, level up a bit to be more attractive. And there are many dimensions to this, and there are many things that are lacking in academia, and that's why I suppose students are going to business. One of them is only now we are forming, I think, world-class level groups, research groups. So I think that we also need to kind of develop world-class research to attract really brighter students in Poland who are on world-class as well, and they pick between industry and academia. There's also a problem that's more systematic. It's not only in Poland, that academia broadly doesn't really, I would say very broadly, doesn't, let's say, care about students that much in a way. So I will give specific examples. So in industry, we invest a lot in giving feedback, having one-on-one meetings, and developing a relationship with employees. Well, at least from my experience at academia, this is almost completely missing. So I would say maybe bringing something from industry to academia where we, let's say, develop better talent and kind of invest in students as well is also one direction. But this is broadly about academia, not only academia in Poland. Salary gap does exist as well abroad, and I think this is not the biggest contributor to the fact that students in Poland don't want to do PhDs, for example. I think the main reason in Poland, though I guess it's mostly a question I think to many of you in the audience, is that Polish universities are not, for example, having a degree from a Polish university is not as prestigious as having a degree from, I don't know, Oxford or Cambridge. So when people go abroad to these universities, they often kind of invest in themselves to have such a degree. So I think we should in academia, I guess I'm thinking as well about myself as part of academia, we should really think about from first principles, what is the reason that students are choosing a different path and kind of work from there.
Yeah, so maybe if there is, so big competition for the resources, there should be more opportunities to collaborate with the same resources. And this is where we actually arrive at this challenge that Pablo mentioned, that the overarching goal for research and for industry, they can be completely different. Like with research, you work on something, it has to end up with a good paper. Otherwise, it's more maybe you learn something, but it can be a waste of time. And in industry, you don't care so much whether it ends up being a good paper. You have to build a good solution. It doesn't mean it has to be novel. It can be a little bit novel. You don't have to, spend some time comparing it with other methods, other, previous state of the art, and so on. Maybe you would like to, on the other hand, spend more time, let's say, analyzing some corner cases and stuff like this. And as long as we have those differences in the overarching goals, it will be always quite hard to have a very, easygoing collaboration. And another thing that I wanted to mention, because it's overlooked because it's relatively small, but I can see it, popping out more and more, is licensing. In academia, you create a lot of stuff that is not very permissive in terms of commercial use. You have cases in which you have data sets that can't be used for commercial use, and then you have, for instance, models built on the same data sets that have different licenses, maybe more permissive. But then if you are in the industry, why would you spend time with something that you are not sure whether you will be able to use it later on? Even if the model can be used, but the data cannot be used, what if you need to go back and maybe, change something, maybe reuse this data? So this is, another challenge, and for some reason academia is not very willing in terms of creating those more permissive licensing.
Yeah, maybe I think this is actually a big issue that is on both sides. I would a bit broaden the problem. I think there is a problem with, generally speaking, intellectual property rights. And so both sides, I think, have requirements that are not consistent with each other. So often industry wants to collaborate with academia in a way that they take all the intellectual property resulting from the work. And the issue is also on the academia side, where often let's say, lawyers from the academia often don't negotiate for a win-win situation. For many of you in the audience, this might be, I suppose, a pretty cryptic problem, but it does contribute to a very reduced number of collaborations where, simply speaking, industry just, or the other way, academia just says that it's not possible, right, and rejects an option for collaboration. And this is, again, this is not only in Poland, but overall. So maybe one way, maybe to further this direction of, if we have limited resources, I kind of work better with them, maybe we can have more standard deals, which are more win-win for industry and academia, to kind of streamline how we do collaborations.
Yeah, just to add from that, to that, that's how, for example, in US, agencies like DARPA and things like that work. Usually, you have a three-way agreement that introduces this party who is sort of like the arbiter of the whole thing. But yeah, having a standardized way to cooperate is important. We also notice this from our side. There are methods that are very interesting and have a clear path to industry. And usually, it's complicated to fight through these licenses and come up to a situation where both academia can benefit from all the work and investment that they did, and also industry can benefit from, productizing this type of research. So but again, as I said earlier, it all boils down to this conflict in objectives, which is usually not trivial to resolve.
Thanks for your answers. So one route, I think, which might be beneficial for both academia and industry is doing a PhD which is sponsored by some sort of company. But I rarely see this in Poland. Maybe you have some thoughts about that.
So, in a sense, yes, I have. So, I mean, you probably know that IDS is a company, no? IDS NCBR. But, I mean, we are not, we are in the same time a research institute. So, in a sense, what we do, I mean, we try to run, we started a PhD program, which is a nationwide kind of program. We are signing kind of joint supervision agreements with several universities in Poland. So, for example, with Jagiellonian, University, or Wrocław University, or Warsaw University, which should happen, I hope, very soon, or even Warsaw Military University. So in a sense, we kind of do this, but kind of the reason is maybe different. So you should think about ideas not really as a company, but more about research institute. So we really try to give a possibility for people to do a PhD and to concentrate on research. On the other hand, I think, I don't know, I mean, this is with respect to some companies like Nvidia or other ones. I mean, they are not, maybe, I'm not sure it makes sense for them to actually sponsor a PhD, you know? I mean, there is this industry PhDs and you know, I mean, I don't think this is really working. Yeah, so this is my view. Because, I mean, kind of, it's not, I mean, there are things which kind of are not aligned, as you said. I mean, you want to keep your IP, and then really what's in your PhD when you do your PhD from industry is not really, you know, so open, and you usually cannot publish your data. And right now, if you really want to have a good paper, you should publish your data. You should publish all your code. I mean, it should be kind of available to everybody. And then it doesn't really align. So I mean, we need to do some work to actually have it. And somehow, I would totally agree with what was said previously, that we really need to build up some top, you know, research groups here. Yeah. So we try to do this at Ideas. I mean, to attract top researchers. I mean, to start research groups, to really give them resources to have some seed, you know, research and top, you know, quality research being done in Warsaw, so that more people will actually come, more students will come. Maybe they, you know, will compete with you know, Oxford at some moment of time. In some senses, we do in theory, in theoretical computer science. I think Warsaw has really huge, you know, esteem, really educating, you know, top quality people in algorithms, for example. But I mean, we should just do it and start, you know, educating top people in ML, and I think this will happen in few years. And
so if I can.
Yeah, sure, go ahead.
Yeah. So yeah, partly what you say. I mean, there are some points of truth in there. Just want to give the perspective of Nvidia here in particular. So in Nvidia, we are right now in the process of introducing the industrial PhD. But me, for example, I did my PhD not as an industrial PhD, I did it while working. So this came as a great cost to my personal life. But the point is, you know, an industrial PhD at Nvidia, to me, it means that you don't need to go to Oxford, you don't need to go to Cambridge or to USA to take your PhD to the next level, right? You can do this PhD at that level that you want to be, or that you envision yourself at, and at the same time that you acquire this experience in a company, and you have, let's say, a framework that allows you to, what we said earlier, to preserve your academic objectives in the industrial setting where objectives can be a little bit different. Now, when it comes to you know, your ability to deliver impact, as it was mentioned, about your ability to publish data, this is dependent on the topic that you are going to be working on. Example, if you are working on a deep learning model or deep learning architectures, by all means, you want to make your work public, you want to publish papers, and, you know, as much as possible, make this research reproducible and release the data and use publicly available data. On the other hand, if you are working on different type of technology, like, for example, new advancements in hardware or things like that, which can become a trade secret or a commercial advantage, it is possible that some of these things are not going to be published from the very beginning. But this is going to happen in the same way, whether you work on academia or whether you are going to work on industry. Because we see this formula happen many times. We see how companies in the US, for example, they deliver a breakthrough in silicon design, for example, and their best way to make this thing available to the public is not to go to a conference and say, hey, let's give away all this for free. They spin off a startup and they start commercializing this idea. And this thing has happened many times. Now, when it comes to the industrial PhD, this is a formula that has its pros and cons. But we have folks at Nvidia who have gone through this path. And you know, as I say, I decided to do this thing not as an industrial PhD because I wanted to have more freedom. But I can understand why people would like to take their PhD to the next level, to the top level, let's say, doing this type of thing at Nvidia. And it doesn't require them to go abroad and to plan this huge move. So yeah, in my opinion, this is a positive thing. But you know, it might be a reaction to a situation that we have in academia, a stopgap measure for people who want to have like this very, very, you know, over-the-top PhD without having to go abroad. That's my point of view.
Yeah, so I think it's very challenging from the company's perspective to commit for such a long period to, let's say, 1 or 2 topics that this, you know, person doing industrial PhD would want to execute, and you know, it has to make some kind of this person has to stay with those like 1-2 topics during let's say 3 to 5 years, and because of this, I'm like quite skeptical. How can you execute this? Because you know, in industry is changing. You are looking into new methods. Maybe you would like to focus on something else with your product. And it's just hard for me to imagine that for, you know, a lot of especially smaller companies, they would like to invest in something like this. But in theory, this, you know, marrying PhD with industry, this is something that we should try to make it work. So maybe instead of let's say creating a whole industrial PhD program with this one company, we can work for solutions where during your PhD would work with, say, 4 different companies more on a like project basis. So let's say if there is one specific topic and you discover that this can be used in some, you know, commercial project, you work for like 6 months with this company, you help them, you have some, you know, exciting data to support your research, and then this becomes part of your research. And this way there wouldn't be this problem with commitment, but also a lot of problems with you know, those mismatched goals that we talked about earlier on. This maybe would disappear.
Maybe a follow-up question to this, but wouldn't be switching between projects defeat the purpose of a PhD, which is like to have this deep dive on a particular topic?
Yeah, but this way, like, you can have deep dive in a specific topic, but the same method can be applied for many different companies, possibly. So let's say, you know, you are working maybe on image segmentation, and you have one collaboration with one company that does like satellite imagery, and then you have another collaboration, but this time you are working on a completely different data set, maybe medical one or so, and you would dig very deep in terms of methods and everything, but in terms of different applications. And I would assume people thinking about industrial PhDs are thinking about applying the methods and not necessarily just, you know, researching novel ones. They would get exposure towards many different verticals.
Yeah. I really like this idea, and actually, you know, it's not like then you need to work, be employed by the company. Yeah. You can be employed by academia and work for companies. So this makes sense, of course, that I think that research groups are working this way. If they are open for applications, then researchers support companies this way. So talking about PhDs, I think that there are 2 parts of this process. One is the research part, and second is the certification. So the certification is easier because you can actually create good research, you know, publish papers, and just go to academia and do external PhD. Just pay for the review process, and you can do this external PhD. So what really matters is this research part. And the question is when you can find a strong research group to do good research. Is it easier to find this strong research group in academia or in business? So maybe it's not clear, maybe it depends on the actual topic of the PhD, but I found that this industrial PhD, in Poland at least, maybe it's not a best solution because the idea is that the incentive is for PhD student to get higher scholarship, but then he or she spends most of time in the company, and then just going to university to get some grade or something like that. So maybe it's not the best way because not always you have strong research group in these industrial settings. And then it's really hard to do good research if you do not work in a strong research group. So in other countries like Germany or France, it's working slightly different. Like then the collaboration between industry and academia is like people that are employed are kind of, going to academia, working with people in academia, staying physically in the research labs in academia, and then they can do some really serious research and getting some new experience, new knowledge. Then they can return to the company, and company has not only a new PhD student or new PhD person, but also skills that were developed, processes, new perspectives that were developed at academia. So I guess that we should look for opportunities to do these more applied PhDs. It is not clear for me if it's needed that the person needs to be hired by industry. Maybe we can look for some, different solutions, win-win solutions.
Like maybe to what also you both said, there's one path that I think many people actually take, which is do PhD based at a university and then do like internships at different companies. And I think this works very well also abroad. So maybe that's one way to have like industry PhD without industry PhD.
So, I usually discourage my students from doing, like my PhD students from doing internships at companies, which might sound surprising.
But why?
Why? Because nice. Most of them actually complain or come back. They mostly do it from financial reasons, and they go to, I don't know, say, there's a company starting with G, and they come back after the summer and say, I did not do anything interesting during the internship.
Sure, you have to do it right, but...
No, but it's super hard to actually, put the guys into the place when actually research happens and they actually can take advantage for their PhD. Sure. So I think it really rarely happens that this that doing an internship at industry will actually it will contribute to a PhD.
Sure,
So
that's a fair point. Yeah, but I would say that also there do exist, opportunities like that. Maybe it's about being much more picky about them.
Sure, but still, if you think about, if you really consider, research path and academic path, you should concentrate on it on, 100% or even 110%. There is no kind of choice. If you really want to excel and be excellent researcher, you should just do research. It's not going away would actually make it way harder to be top researchers. Think of it that in India there are 100 more students than in Poland, and even if 1% of them would work like 110%, we are lost. Meaning you will need to compete with much more people, and if you don't really do your concentrate on research, you will not become top researchers simply. This is a thing which I try to kind of convey, and if you really want to concentrate on it, just do research. It's of course hard. PhD student scholarships are very low in Poland, and so you need to find a way, and one way would be, of course, I'm advertising ideas, but this is kind of
there
thing.
are other ways.
No, another way. I sorry, that's my job, and I think I'm really happy. So I did a PhD 20 years ago. My scholarship was 1,000 zloty per month, and I did it. I struggled a lot, of course, but I really fought for kind of creation of a project or program that would kind of give a better chance for young people to actually do research in Poland. And then I'm really happy it happened. So I will keep on advertising ideas. Sorry.
Sure. I mean, can I quickly? So maybe last. Like, I think that you can kind of have here a cake and eat it in a way. So indeed, it's easy to lose focus, and I suppose this is true both in Poland and abroad, where because it is a theme as well abroad, where people in top universities very often go for internships at DeepMind and stuff. I would say if you're smart about it, I would personally very much recommend this. It's a way to add diversity. Like one of the key issues in academia in Poland is that we inbreed our own ideas instead of, I mean, sorry, ideas is here, very unfortunate. But we kind of stay within like very narrow topics. But by going abroad, or just by going to a top company, do research, I agree, if you don't, then it doesn't make sense. You can kind of gather ideas from different places and distill them into something much better than instead of if you were to do it on your own in like one place. And it's true with it's also true with deep neural networks, right? So if you train multiple deep neural networks in diverse way and combine them, they are better. And I think it's also true in research.
So I wanted to comment on this discouragement for internships. I think maybe, Piotr, the underlying assumption that you make is that people should focus 100% on research because in the future they would like to focus on research. Whereas maybe like if you are doing a PhD in theoretical math, then this is more or less the only path. But many people that are considering doing a PhD in data science, AI, and all those fancy topics, they are not, I would say, not 100% sure that they would focus on research later on. Maybe they would like to go back to industry. And from this perspective, trying out many different things, internships that might be boring, this is not necessarily a bad idea. I did an internship that I didn't like, and I still think it was a very good idea to do this because I learned about stuff that I don't want to do. And when you are young, you have to do this, and you have to be exposed to many different things. You won't make a decision for the next 20 years, just by sitting and researching everything. You have to try.
Yeah, I guess it's good to try, but it's maybe not that good to do many things at the same time. Yeah, and this is the difference. Like, okay, try this, choose one, and then focus on this.
Yeah. If I can say something very quick, because the discussion is getting very interesting right now. I think that doing an internship during your PhD, maybe not doing it all the time, but maybe in the summers and things like that, it is extremely valuable. Because the worst thing that can happen is that you learn, as we have heard, what you don't like to do, which is a very important thing you need to learn as soon as possible in your career. In the worst of the cases, in the less worst of the cases, what you are going to get is you are going to improve your skill set. You will probably learn good practices about programming. You are going to learn about CI/CD systems, things like this. And all this will make you better at writing down ideas, experiments, and executing them much faster. I have seen this situation work, and I see some people in the audience who did internships in my group during their PhDs. And talking with them afterwards, all the things that they learn, how do we manage projects, how do we track progress, how do we make sure that ideas are good, these are something that they incorporated in their PhD, so that made them less dependent on their supervisors. They are able to pursue their own ideas, increase the levels of success of their experiments, and moreover, work much faster towards their objectives. So I think that is a net gain to do internships. Of course, you need to focus on your research, but the worst thing that can happen, A, you will discover what you don't like, B, you will learn to program a little bit, you will learn, systems engineering, and overall these are learnings that you can take to your own research and then become more independent and more successful. This is I've seen this happen, so I truly believe that that's the case.
Well, thanks for your discussion. I have maybe let's stop for a bit and ask a question: why would anyone do research? What are the reasons?
Sure, I can start maybe. That's a good question. So I suppose if you have like this itch that needs scratching, like you should do PhD. It's usually not the best reason to do PhD if you do it to, I don't know, like for example, get a position somewhere that requires PhD. Then I guess you might fall into one of the kind of traps that we have been discussing. So yeah, I think if you're like really passionate about something that you like kind of feel it has to be solved, I think that's one of, I suppose, many, but one good idea to do PhD.
Okay, so I will talk from personal experience here. So earlier in my career, I started as a software developer. And in one of the works where I used to work in Dolby laboratories, these guys of the Dolby surround and this type of thing. So I was working very closely with the research group, and I quickly observed that our work was different. The more I understood the type of problems that the research group was trying to solve, the more I started falling in love with the idea of research, where you don't have, let's say, a very clear idea. You know where you want to get, but you don't know very well what path is going to take you there. So let's say the whole process of exploration for me was very interesting. Exchanging ideas with colleagues, trying new things. And what really, let's say, sold me on the idea of research was that when done right, you could try new things and not be afraid that they were not going to work out. You always had a second chance to try a new way of addressing the problem. And I discovered that a bit later when I had already started working, and it was expensive, as I said earlier, to sort of like reroute myself. But why to do research? What I enjoy the most is the pursuit of answers, the opportunity to exchange ideas with people and to work on open-ended problems, because it is something that I never get tired about. The problems change, but the thrill of discovering new solutions still remains. And I'm very lucky at Nvidia to work with top researchers, with very, very smart people, much smarter than me. And I discover new things every day. And the same can happen to you in a research group here in Warsaw or wherever. So for me, it just makes me happy to work in a setting where trying new things is encouraged, failing is not the end of the world, and people are open to try new things. I just find, I don't know, like I have this romantic view of research, but after so many years still remains. And if you really like this if you have this soft spot for solving this type of problems, I would invite you to try it. It's tough. Sometimes it's very frustrating, but whenever you are successful, it really feels like you, I don't know, achieved something great. So that's my take on that.
In general, I would agree, but something which I think I enjoy a lot. I mean, is sharing the knowledge. I mean, if you in academia, I mean, you are free to do whatever you want with the stuff, and kind of you probably heard about the guy from this. He was in newspaper like Duda, yeah. From not the president, the researcher from Krakow, who invented like this, compression protocol, this asymmetric numerous compression, and he kind of, was really happy to share it with everybody. And this is only possible in academia. Yeah, and right now, even for he shared it with the world. I mean, he needs to fight with this evil companies who try to actually patent what he did. No? I mean, which is super surprising and kind of annoying. And I mean, if you, I think kind of for me the biggest kind of thing and the thing I as I said I enjoy it most is to be able to freely share what I do.
Yeah, I guess it's a very personal question, and there will be different answers. But for me, it's about freedom. Like you can choose to do whatever you want, and also there is a very rewarding feeling after you see a problem, and then you can work on the problem. After day, month, year, decade, you can actually solve the problem. So it's really a rewarding feeling.
Yeah, so I think especially in like theoretical research, the nice thing is the beauty of it, because you don't have to focus on whether you can focus on the part of the solution that it's just this beautiful way of solving something, and you don't necessarily get it in like practical applications where it's more meaningful whether the problem is solved than the way in which you arrived at it. So I think if you have this itch that needs scratching, that as Staszek said, and you really find the beauty in all the maybe proofs or stuff that you see, then you can pursue this path. If you don't have and you still like working with innovative stuff, then maybe you should think less about research, like theoretical research, and more about stuff like R&D, where you have this development part in the name, and you can still focus on things that are novel, but you get this satisfaction of actually, so you not only get this satisfaction from coming up with the solution, but you also have this, let's say, more development type of work that's more like everyday normal job. So it's also worth considering.
Thanks. So I guess the next question is, what are the advantages of working in industry? I think someone will have the answer, right? Staszek, maybe you will start.
I can take that. I don't mind. You can start.
I can start. I know many, just like in academia, these are very complementary places. So for industry, I suppose one thing that's interesting is that you can work on problems at scale. So it's hard to work with, for example, scaling large models in academia, and this is a very exciting field. You can work with large laboratories, which also is something that's difficult to achieve in academia. So I guess one feature of many is just working on very large problems. I think that's interesting.
Yeah, from my perspective, again from Nvidia, the coolest thing for me of working in industry is that people are actually using what you are doing, and at the level that we work, because Nvidia is not a company like Apple or Amazon or Google. We don't have this search website where you do something, or I don't know, this huge portal where you can buy stuff. Our product, let's say, is our hardware. And when we improve it, let's say every time that we make a tiny improvement to CUDA, what we see is that this thing makes it better for millions of people who are working on a ton of different problems. And you see that somewhere somebody built a huge model of the Earth to model the climate, and they want to help fight climate change, and they are running it on GPUs, and that's great. In the other end, you have somebody working on protein folding, but they are all using the same bricks that you are helping build. So you are enabling all these people in their pursuing their research or products and whatever, and it's just great to see. So actually seeing people using your stuff, not only sharing it with them in conferences, but seeing them using it, it makes you really proud. At the same time, one of the advantages that I see is, I wouldn't say unrestricted, but you have access to a very large amount of hardware. We were speaking earlier, for example, one of the projects we have at Nvidia is MLPerf. If you don't know it, it's sort of like the Olympic Games of machine learning. You have all the hardware manufacturers competing who is the fastest. So in order to be successful at this project, you really need to, deploy workloads at scale. So you are working on a cluster with 4,200 DGX A100, which is an incredible amount of compute. And you can, we were saying scale workloads, but you can explore problems that are out of the scope of what many people can do. It also connects you to very large research labs. So I would say that the scope of the problems and the impact of the problems that you are going to be working on, can be truly great. This doesn't mean that you cannot achieve that in academia, but in some companies it's there just by design. So I would say that impact, access to smart colleagues, and seeing people using your stuff and how it makes a difference, it's for me the most appealing side of working in the industry.
So, yeah, I will be kind of a bit hypocrite, I guess. So some 7 years ago, I started a company And so I do work in the industry in the same time, but I will keep on advocating in a sense, you know, for research as well. I think, you know, working at industry is as well interesting. I mean, you get to really know what's applicable, you know, how to, you know, in a sense, turn your research into things that you know, do things, improve things. I mean, in MIM Solutions, we are currently involved in several medical projects where we try to apply AI to solve to help doctors make the right decision. And I think it's super interesting. And we try to do things, I mean, in a sense for good, I mean, to help people. And somehow, what I would encourage you to think, I mean, is to some of us did it, and I guess 3 of us started our own companies, maybe more will do soon. Przemek, no? Yeah. So most of them did it, and I would kind of encourage you to consider, you know, doing your own stuff. I mean, thinking of how you could, you know, found a startup and you know, do things where you really can steer in the direction you like. I mean, something for me, the interesting part of having you know, my own company or kind of being involved in my own company is that I can really choose the direction of this R&D works myself. So if we are interested in, you know, looking on this information, for example, then we started the project and we do research, in a sense, research on this and try to help, you know, companies and public bodies to actually fight this information in Poland. And, you know, so this gives you more opportunities and kind of really more freedom to do things. I mean, it's very different from what you would do in academia. I mean, it's really more challenging to publish papers when you're in a startup, for sure. I mean, maybe in an industry like big industries, this is easier, but in startup, you usually have no time to actually write this paper at the end. And maybe you don't really want to share your IP, maybe you don't want to share your data. I mean, that's more challenging to actually publish.
So I was working for a few big tech companies like Samsung, NetEase, IBM, and I like 2 things. I remember 2 things, and I really think that it was a really nice experience. One is the diversity. Like quite often in research labs, you have very similar people with very similar background. Like if you are ML researchers, it's quite common that you are after very good, you know, secondary school, focused on math and computer science. You are then in very good, after very good studies and so on. So these guys are pretty similar. They have pretty similar perspectives. In large companies, it's quite often different because you need to have a department related to developing products, handling problems, contacting with customers. So if you like diversity, then it might be nice to learn these different perspectives. And then you can one day collaborate with people from product and second day people from consulting and so on. So this might be a nice experience. And second thing is processes. I think that to run a big company, it's super hard to develop processes that help people to operate at that scale with super complex communication between very diverse people. So my experience from Samsung Academia, from Samsung NetEase and IBM is that sometimes they are painful processes, but they are really needed to support teams to operate well. So I think that still, even if you are thinking about doing serious research, at some stage, maybe it might be nice to spend some time in industry.
Yeah, so something that I would highlight is definitely the short feedback loop that you get. So you work on a project, you finish it, it doesn't take years, very often it takes just months, and at the end of it, you present it to the client or you integrate into your product or whatever it is, and you can see whether it works, whether it makes sense, whether it really creates impact, whether on the financial side, maybe it's a new feature for your client or whatever it is. You can clearly see it like just after finishing it, or even at the time of working at it, which usually brings a lot of satisfaction, and this satisfaction can sometimes be almost perpetual. And another thing that's worth highlighting is that when you look at research and all those, let's say, state-of-the-art methods and everything, like without any applications, it would be for me closer to art. Like as long as it's not used for something, it's just, you know, puzzles, so to speak. So, you know, when working in industry, you have this state-of-the-art and state-of-the-practice, and you can try to push this state-of-the-practice to be closer to the state-of-the-art. So you really, you know, by sort of taking all those novelties from research and academia and trying to apply it, you push everything to be useful. And this is I think also, you can have a great satisfaction in this, because this is what actually makes most of those methods worthwhile.
Thanks. I guess I will have one more question, and then we can go to audience with questions. So maybe, how do you give opportunities in your company or in your research group for people who come to develop? And I would like to maybe hear like a concrete example rather than different words, let's say.
So maybe I can take that one first. So how do we give opportunities to people who would like to do this type of thing? So at Nvidia we have different formulas for that. So something that we do first is we cooperate with universities. A good example is the University of Warsaw. We've been working with the University of Warsaw for a very long time at Nvidia. And we have this ZPP. I wouldn't be able to say that in Polish, but it's like some joint project that we do with Warsaw University students, usually for their bachelor thesis or master thesis. So they have an opportunity to work for a year with us in a group on some projects that we decide together and that we offer them. And this is usually a good exposure for them to research topics, to Nvidia technology, to a little bit of, you know, the way to do research in a systematic way. But the main way that we, you know, give opportunities to people is through internships. We hire a ton of interns at Nvidia, not only for Warsaw, but also, you know, you can apply to our internship and go to Santa Clara for the summer if that's what you want. But you know, we grew our office from 3 employees to, I don't know, 100 in 3 years. So we gave a ton of opportunities. Nvidia has been recruiting from Warsaw University for ages, but we also, you know, recruit from Jagiellonian University, from Warsaw University of Technology, and usually the way it works, or the way I like to think about this is, especially with interns or with junior engineers who don't know very much. I really love that because they don't know what is possible and what is impossible. So I usually give them something that is impossible, and many times they just come back to me with a solution, and that's actually great. Right now we are finishing a paper for CVPR that started as one of these impossible problems to solve, and we found a very creative solution. So yeah, through cooperation during your studies, internships, this is how we support people who would like to get in this field. If you are more senior, more late stage in your career, there are always projects that can benefit from people who have research background or strong engineering skills. So yeah, we live out of that. We want smart people who will help us solve difficult problems. So yeah, if you are, so yeah, just come apply.
Yeah, so for us, I think there are 2 things, and one would be making sure that the projects that we get are actually challenging enough, and this is, so to speak, focusing on things that are more bespoke, that, you know, our clients tried to do themselves and failed, that they maybe, you know, achieved a certain degree of accuracy, but it's not enough with the methods that they tried, and this, you know, creates opportunity for people to work on those more novel methods, and as I said before, like get state of the practice a bit closer to the state of the art. So one would be getting those interesting, challenging projects, and the other is to leave, let's say, enough room for people to get interested in other stuff and then organize themselves to execute other initiatives. And this is something that we also presented yesterday with this Trailbird model. This was actually not a commercial project for us. It was a bunch of people that thought, okay, we can do this cool stuff with NLP, and we support such initiatives because it not only helps people to develop their own skills, it's also a good thing to do in general.
So I guess the question was about concrete examples of collaboration, yeah?
Not collaboration, but kind of opportunities, and not only in industry, but also in academia, right? So how can person develop their skills further? Working, for example, in your lab, right?
Okay, so no, I think it's a really good question, and so Piotr is advertising ideas, so I will advertise MI² Data Lab. We have like 3, let's say, legs, and one of them is solutions, is more related with commercial applications. So the idea is that we have people with deep knowledge about XI or other machine-related methods, and then some company will come to us and will look for advice, and we can engage our researchers in such applied projects for some short period of time. Second is research. So usually this research also is concentrated on something. Usually we start with position called research software engineer. This is a position that anyone after a computer science degree can come and start developing some software that can support research done in the lab. And usually after this, sometimes it's week, sometimes it's month, sometimes it's year, this period, developing software, understanding how we operate, some people are more and more interested in doing some research. So they find their own questions that they would like to answer, and then they do this. The third leg, and we treat this pretty, I think it's really important, it's about education. So again, academia and business, I think in both places, it's really important to think about education, about new people, because resources are rare, and we need to train more people in these spaces. So the third leg is related to creating new materials, giving lectures related to the new methods. So usually people with these 3 different, let's say, backgrounds come to us. Some of them are interested in giving lectures, some are interested in research, some are interested in more engineering perspective. And what is nice that we can actually mix these 3 legs, and then people see that, okay, we can combine these 2, we can focus on this, and after 1 year focus on another. So I guess it's good to have this group of people with kind of mixed, let's say, needs and skills. So yeah.
Sure. So in terms of concrete examples, I suppose internships are a really nice thing you can do, and that can be very interesting, and also something we do at Molecule. Just listening, I think that one thing that maybe we do in Poland too little, and that could be interesting, is companies sponsoring like longer term research. I think that's something that's in Poland is a bit missing. So like instead of sponsoring work inside company, like maybe sponsor a PhD based in a company. I think it's not always a good match, but for bigger companies, I think that could be like an interesting complementary way to give opportunities.
So, I'm not sure I give a concrete example. So, but I think something which I value and I try to do in like all the 3 places I kind of have been working or kind of contribute to, to really give people a chance to do, very interesting projects, related, something that helps people. On the research side, like, for example, I really try to do my PhD, to give my PhD students like, chance to really concentrate on doing research and to excel. Like, I think all my PhD students had this A-star, publication on a conference. And on the other hand, in company like MIM Solution or Ideas, we really, try to do interesting things. I mean, I think it really is happening, I hope, at least like in both places. At IDS, we really have tried to attract top kind of researchers to do super interesting research projects. At MIM Solutions, we try to really engage with as I said, for example, with medical applications to really deep dive into how to help people, you know, be more healthy. I mean, contribute to how the medical system in Poland works.
All right, thanks. So I guess right now is time to ask questions from the audience. So I guess we have time for 1 to 2 questions.
We can stay over the break, no?
Okay, yeah, of course, if you have time.
Yes, okay.
Hi, thanks for the amazing talk. And I wanted to ask if you think that actually the industry work can trigger the need for some research. For example, in MLOps or AutoML, I think that the need actually arose in the industry for research in those areas. Would you agree?
Yeah, definitely. I mentioned very briefly scaling big models. I think that's one. Like scaling big models, that's industry, but understanding big models, that's something that will probably happen in academia, or at least partly in academia. There's also, I think, in more bio-related stuff, which I guess I have some familiarity with. Now, a trend that's emerging is connecting models with laboratories in a closed loop, and there it spans so many interesting problems. So I think, for example, research in continual learning and active learning is a bit, I would say, stale a bit, like it's or maybe slow. And I think part of that reason that we don't see that many advances in active learning and continual learning is that there is not yet an industry that would like let's say further it. And now with robotics, with other applications of active learning, I am expecting, for example, much more research in these areas in the future.
Yeah, so I would like to answer this question because I recently was talking about MLOps at work. So the way I see it is like when you pioneer something, so you have these cycles, and when research grows, let's say you are making this concentrated effort on research and you are getting some results, and it eventually starts scaling and starts plateauing because the complexity doesn't allow you to progress any further. So these seeds that you are planting, or this new breakthrough that you are creating, projects some shadow, let's say, conceptually, and in this shadow you have a lot of efforts that can develop. You are basically creating something that didn't exist earlier. And going back to MLOps, I really like this counterexample because you could say that MLOps grew at the shade of deep learning. So you have some research that spawned a new area of engineering, for example, and that actually shows that research not only creates room for researchers, it also enables engineers, and it also enables new roles that didn't exist back then. And eventually, all this engineering effort starts growing, and it eventually plateaus again, and it crosses with the value that had been plateauing earlier from research. But when these two lines meet, then it allows the research to go to the next level. So you have this cycle always where research grows, plateaus, and then engineering follows suit. And these are, at the end, productivity tools, you know? So it means that there are many different ways for you to work in deep learning, and maybe you will not be developing cutting-edge methods because of whatever reason, but this doesn't mean that you are not going to be effective, because you can work on MLOps, for example, be really good at it, at scaling systems and things like that, and you first can make a very good living. Second, this work is very interesting. And third, as time goes by, new opportunities will appear for you. So MLOps right now, I would say, is fundamental for doing deep learning at scale, and in the future it will be something else. But yeah, that's my observation. And right now, without MLOps, we wouldn't be able to do anything. Yeah, at least at the level that we are doing it right now.
Yeah, just one comment here that I agree that it's fundamental, but I would also point towards industry, that it's industry's job to make sure that we have the right tools, that we have the right processes, that we standardize stuff, because this is where everything is being used, and only when you start using all those algorithms and you have all this complexity added to the systems, because you start to use those predictions, and not everything works in the way it used to work. And then you need to develop those new tools, and I think you should look towards industry to make sure that we have them.
Hi, thanks for the interesting discussion. Oh, okay, maybe I stand up. So I'm just interested, what was not mentioned was somewhat part-time things, because from what I observe, many teachers or people in academia, they actually still sneak in some jobs on the side, because regardless of what we said, I think money is important in life. And what I observe also, we spoke more about PhDs, but I wanted to mention the teachers, right? So I think some of the best teachers are the ones who know reality and know industry and real life. So it's highly appreciated to have a teacher who had some experience in industry, right? So what about accepting this and just allowing people to do some part-time in the industry and some part-time in academia, and just trusting in their own survival instinct that they will do good choices without funding their PhD, but just giving them time to do what they think is best for them, kind of thing.
So maybe I can start. I totally agree. For teachers, I encourage university teachers to work outside academia, to have contacts with the real world. I discourage PhD students to do it.
Yeah, I mean, indeed, to do PhD part-time in the industry, it's very challenging to focus, right? So, let's say alternating between doing full-time research and full-time industry engagement it's just easier to do. When you have two things, very often you won't do either very well.
Yeah, I think the challenge lies in the proportion. So if it's 90% of the time being spent at the job and maybe 10% spent on the university teaching, then it's probably easy to organize, and it can be beneficial definitely for the university. And at the same time, it doesn't create such a challenge on your main job, because 90% is almost 100%. It's very hard to accept people doing two things at around 50%, because it's all about the cadence and how the work is being organized. If you work on a project and all the other people give 100% and you give 50%, it's a bit challenging to organize everything. So I think of course, we should support this, but also for people considering this, I think it's important to know what's the main job and what's the side hustle, so to speak.
So I guess that from a perspective of university, it's important that teachers are doing the good job. So if they can do good job working in both places, that's great. If there is a synergy, if there is no synergy, this is a problem. And I see in both departments, MIM and MINI, I see many examples in which you can actually combine experiences in academia and from industry for teaching, because then you can describe some business use cases, you can share your experience, you can talk about your path, so this can be done right, but it should be transparent.
So my point of view on this is that it's good to combine work in academia and industry if you can, but what the worst part for me is the context switching, right? So if you are able to minimize that, that's much better, because at the end of the day, it's not about what you are doing now. It's like what you are able to sustain in the long term. And if you are involved in many things, but you are able to manage them in a way that it doesn't generate you stress, and you are able to achieve this state of flow because you are immersed on something, you are concentrated, then you feel you are delivering, even if you are doing it part-time, right? The problem is when you move back and forth in a non-controlled way, which starts creating you this stress that is not manageable in the long term. So I know this for a fact because I did that myself. And what I would recommend everybody is to think, what can you manage in the long term? If you are able to do a PhD and then have an internship 3 months in the summer, that's great because you can concentrate there. But if you are going to be doing a bit of PhD in the morning and a bit of company in the evening, 3 days a week, and that's gonna cost you, you know, and you have to manage that, because at the end of the day, work is important, research is important, but your life, your family, your health is even more important. So that's what matters to me. Yeah.
And it's not needed to hold PhD to teach.
I think we have time for one question more.
Okay, so it will be a kind of a mean question, but it's mean by design to encourage discussion. This was the disclaimer. It's mostly directed to Piotr and Przemek, I guess. Imagine, because you both represent academia, but also run your own companies, as I understand. So now imagine a breakthrough idea born in your company. Do you publish a paper straight away describing this idea?
Yeah, so for me it's a very easy answer. We are doing this exactly like that because the business looks like it's based on this open core approach. Like the tools, methods are open. We create solutions around these tools and methods. So the best possible approach will be to publish this and then develop some service solutions that can be monetized.
Yeah, but somebody else will do it.
We need to be faster. We need to be faster and better.
Yeah, so maybe one comment here, even though I wasn't asked. Business is not just about ideas, it's very much about execution. So, you know, many businesses, if you think about, I don't know, Uber isn't revolutionary. It's not. It was about executing it. It was about having enough funds to be able to execute it. And it's not always, you know, the idea that you have to keep secret and just by yourself. So I don't think it's always a challenge here.
Yeah, I think that industry has this bias for secrecy, which I think is counterproductive often. Like, I don't know, there's a patent for dropout, for example, so in case you didn't know that. Yeah, I think that it depends on the particular case, right, what you said. But in general, I think it's often good to be on the open side, as it's often like win-win situation. And we see that a bit with companies like Hugging Face or Stable Diffusion recently in deep learning.
Just one very brief here. So answering your question, like Google, DeepMind have been open developing their methods and putting them in papers for a long time. The thing is, are they truly open? You can publish your idea and you can let people know about it. You can publish your network, pre-trained weights, whatever. But the secret sauce is the data. And if you don't release that, that's the same as, to me, as being secretive, because you can tell everybody, okay, just implement this model and you will, I mean, we give it to you, but if you don't have the data to train this model, you cannot reproduce anything. So sometimes we get all caught up on, we need to protect our idea, etc. But, we fail to understand what's our secret sauce. And sometimes you can give away almost everything. And if you just keep this data that you collected in YouTube and in these 1,000 million services that you own, then, it's the same as, not giving away anything. So where do we draw the line is important. Sometimes we think it's the method, but actually the method is the least important, is the data, right?
So I would say, we have different examples. In some of them, we really thought, had some discovery and decided to keep it secret because, to kind of keep competitive advantage of what we do. So it's not an easy kind of answer. Yeah? So it really depends on kind of what it is and in which kind of place in your company, how important it is for your company. So we have different projects. In some of them, publishing things is not a problem. In other ones, we really keep things secret.
Thanks a lot.
Okay. Yeah, I will thank a lot also. So I guess this really concludes the panel. Thank you for being here. I hope that maybe it will influence you somehow in your career. Maybe there will be some changes. And yeah, thanks.
Thanks.